Let's look at conditionals now. So while we certainly will write a lot of statements in which we assign values to variables or call functions or whatever, like we talked about in a previous lecture, there's lots of times we need to make decisions based upon our situation. Is a value greater than some other value, or two values equal, or whatever? So in C, there's three different constructs for doing that. One of those is the if statement, or if you have a binary situation, you can use an if-else statement. The second is the switch statement, and then the third is what's often called either the conditional expression operator or the ternary operator, and it consists of using the question mark and the colon with values in the three positions: before the question mark, between the question mark and the colon, and after the colon. In terms of how often these get used, in the vast majority of code, I would assume if statements are what are used. In second place, the switch statement gets used a lot. And then the conditional expression operator doesn't really get used that often. And in fact, some people think you should never use it because in many cases, it doesn't really improve the readability of the code. In fact, it makes it more cryptic in many cases. But I'm including it for the sake of completeness. In many cases, when we're trying to use a conditional, we need to ask some type of question. So we need to understand the relationship between values. And so to do that, we need some additional operators. And so notice here we use two equal signs with no space between them. That represents equality. Then we can use an exclamation mark with an equal sign after it. Once again, no space between them. That represents two things being not equal. Then we have our standard less than, greater than, less than or equal, or greater than or equal relationships. So how do we use an if statement? So we have the keyword if, then we follow that by a set of parentheses. Whether or not there's a space here or not is a matter of choice. But within those parentheses, we need to have some condition that can evaluate as true or false. And then if this condition's true, then you do what follows the if statement. And notice here's where the semicolon is at. Don't put a semicolon at the end of this line. So some examples would be, assuming we already have variables x and y created, and x already has a value, we can ask the question, is x greater than or equal to 2? If it is, then what will happen in response to it being true is that y will be assigned a value of 10. If x is less than 2, then we'll skip this statement. Another example would be to ask if y is equal to 10. If the answer is yes, then we'll print y is equal to 10. Otherwise, we skip past it. What if we want to do two or more things in response to something being true? Well, in this case, now we can create a block using a set of curly brackets, and everything within that block will be executed based upon the condition here. So if x is greater than or equal to 2, this will be true. So now we execute both of these lines. Now there is some argument to be made for always including the curly brackets. Let's see why that is, even though I don't always do it myself. So let's say when I write my code, we have this, int a equals, let's just initialize, we'll say this, equal 5, b is equal to 6, and then we have x is equal to, say, 10. We'll come along later and say if a is less than x, then we'll say a is equal to a plus 100. And we'll have a printf statement here. And so a is equal to %d, new line, a. We'll print out the value of b. And b is here because I'm going to use it in a moment. So a is less than x, and so we change the value of a to 105, and b was left alone because we didn't say do anything with it, so that's correct. And so what if we come along later and say, oh, well, what I really want to do was that if A was less than X, I want to change A, but I also want to change B. So I'll write the code like this. I've indented the logic, indented the code to match the logic. We compile it, run it. I got 105 like I wanted, 106 like I wanted. So it seems to be working, right? Well, let's do this. Let's change now X to 3. So now, since 5 is not less than 3, I should not change A or B. So A didn't change, but B still changed. So what happened? Well, because I don't have curly brackets here, what I really have written, even though the indentation doesn't match the logic, is this. This says, if A is less than X, change A, but always change B. So remember that in the C programming language, indentation is there to help the reader. It doesn't really matter to the compiler. So this code always executes B. And so the argument can be made that if I had originally written this, and then later on I realize I need to add in the B part when I do it and put it there, then it automatically works. So now neither of these was changed in response to X being 3. And if we go up and change X to something else that's greater than A, then they both change. So that's beneficial if you want to avoid that type of bug. Now, I personally don't always do it. I'm perfectly happy, in many cases at least, doing this. But note that there is an argument made for always doing that in order to avoid certain types of bugs. So can we ask other questions? Sure. Here, and once again, the indentation is there to help the readability. It's not required. But this says, if count is greater than 23, do one thing, because notice I don't have any curly brackets. That one thing is then to ask the follow-up question, is time less than 45? If that's also true, then Z will be given a value of 56. If count is not greater than 23, I never ask this question. And if count is greater than 23, but time is not greater than 45, I never change Z. So both of these have to be true in order to change the value of Z. Now there's many times in which we want to say, well, if some condition is true, do something, otherwise do something else. And in that case, I can use an if-else construct. So here we can see if, in parentheses, whatever my condition is, what to do if this condition is true, and then here's the else statement, and what to do if the condition is false. So in this example, if x is greater than or equal to 2, we print that x is greater than or equal to 2, otherwise, print x is less than 2. Before we leave this though, let's talk about, well, what if I want to do multiple things in response to each of these? Well, once again, since I'm only doing one thing in response to this being true or this being false, I don't need any curly brackets. But if for either of these I wanted to do multiple things, I would need to include curly brackets. So let's look at that example. So now we can say curly bracket, matching curly bracket. And these spaces, I typically put spaces in here, but they're not technically required, so that's not a bug. So 5 is less than 9, so I did this. If we come back up here, change this to 3 again. So now 5 is not less than 3. Compile, run the code, and you see that I subtracted 200 for both these numbers. So if I was only to do one thing, this would be legal in this case. But if I try doing this, now I'm going to have a problem. Because what happened? Well, technically what I've written here is this. Oops. This says if this is true, do this. Always do this, but now the else is stranded. The else isn't associated with any if statement, which is what the error message is telling me. So this won't work. So what if I have multiple if statements and I want to include an else statement? Which one does it belong to? So at the top here, I've indented the code in such a way that it tricks you. The way I've indented it makes it look like it says, if the amount is equal to 13, ask the follow-up question, is cost equal to 52? But if amount is not equal to 13, come down and print got here. But the reality is, this else statement really belongs with this if statement. So the correct way to indent it, to understand it as a human, is at the bottom. So this really, what this code at the top does is the same thing the code at the bottom does, which is to ask if amount is equal to 13, ask the follow-up question, is cost equal to 52? If cost is equal to 52, then we print the cost. Otherwise, we print got here. But we will not reach got here unless amount is equal to 13, but cost is not equal to 52. If you do want the code to work the way the top part's indented, then I would need to use a set of curly brackets here. So I would say if amount is equal to 13, open curly bracket. If cost is equal to 52, print cost is cost, close curly bracket, else print got here. That's how that would work. So how does an if statement really work? Well, the condition, the condition within the parentheses has to ultimately have a numerical value. And so when we write amount is equal to 13, this does have a numerical value, believe it or not. Now, if that numerical value is a non-zero number, such as 8 or minus 3.4, then it's considered true. So this right here, if 8, always prints non-zero values are true. This says if minus 3.4 will always print minus 3.4 is considered true. But if 0 will be false, so it comes down to the else and will print this. Now, would I ever write code that does this exact thing? No, because it's not really having to make a decision. It automatically will do this every time, do this every time, do this every time. But there are times when you return a value that will have a numerical value, and so it could do something similar to this. So let's confirm that this works the way I said, which is that numerical values are what are being used here. We can actually see those numerical values. So let's see what happens. So int a is equal to 5, x is equal to 5. Let's put that expression here. A equal x. And I'm going to add some other stuff in here to make it clear which line I'm looking at. So line 1 is that, line 2 is this. Not equal. Greater than or equal. And that one, to make it clear, we'll put a 3 there. Compile, run the code. And so what did I get? I got a 1 here, I got 0 and 0. So the 1 indicates truth, a is equal to x, and the zeros indicate not true, or that it's true that a is not equal to x, okay? Or excuse me, it's false that a is not equal to x, because they are equal. So when I ask, is 5 not equal to 5? That's a false statement, so I get 0. And I ask, is 5 greater than 5? That's also false, so I get 0. So within my expression, if I write this, if a equal x, and then say print something, this expression here reduces to the 1, just like it shows here. That's what happens. The computer looks at this, says, what's the value of a, what's the value of x? I'm going to check and see if they're equal. They are, so I return 1 to put in here. So this expression basically says this: if 1. So it's true. I didn't put any new lines in there. Let's do these. So I should clear this. Oops, sorry. We'll run that. It's true, it's true. So this expression gets reduced to 1. And then this says basically if 1, which is true, therefore it prints as true. If I had done one of the others, if a is greater than x, which is false, I'm adding these statements because since it won't be true, I won't see anything otherwise. But it's really seeing this. So it's false that a is greater than x, so it prints it's false. And 0 is considered false. So I get this right here. So that's how that works. So once again, it makes no sense really to say if 8, but there are times when I may return a number from a function, and we haven't talked about functions yet, but I return a function value here that may be numerical, and ultimately it reduces to this. A very common bug when people are writing code is to use an equal sign, a single equal sign, which is for assigning values, instead of using two equal signs, which is checking if two things are equal. Let's see what happens when we do that. Oops. Right? So we have a is equal to 5. And so I write in my code if a is equal to 99, print it's true, else it's false. Now what I really intended was to ask if a is equal to 99, which is not true, so it should have came down here and print false, but let's see what happens. It prints it's true, but without new lines. So how could it do that? Well, here's what happened. It sees a equals 99, and it assigned 99 to a. And then this overall expression has a value of 99. We can see it. Let's come down here. Printf. And we'll just do something similar. A is equal to 1, 2, 3, 4. 1,234. I'll put it around here too. There's my 1, 2, 3, 4. So what happens is A gets a value of 99. Then this expression overall is evaluated. So this reduces to a value of 99. And so then it says if 99, and we just confirm that that means that would be true. So it prints as true. So notice the compiler doesn't tell me it's wrong because maybe that's what I wanted. And there are times people will write code. Now it's somewhat dangerous, but C allows you to be dangerous. Or maybe they do something like this. A is equal to, some function call. Where we call F and it returns a value and assigns it to A. And then overall, if it's returning a numerical value, overall it has an expression. So maybe sometimes it returns 0, and sometimes it returns a non-zero number, and that's what you want. But keep in mind, this is dangerous in many cases because of how that works. But C lets you be as dangerous as you want to be. All right. Before we look at the switch, though, let's see what else we could do. So I could ask multiple questions. So what if we want to do this? These don't have to be in order, but I'm doing this in order to, well, actually we won't do an order just to prove that. 1, else, if A is equal to, say, 7. Equal to -3. So if this is true, it's going to print 1 and skip everything else. But if it's false, then it comes down to the else, where it's common to put these on the same line. From a logic perspective, it really would be formatted like this. All right? And this is the same way. But now, it says else do this, but if this is false, now do this. So logically, this is what's happened. If this is true, do this and skip everything. But if not, come down and ask this question. Is A equal to 7? If true, do this, skip everything. Otherwise, come down to the else and do this. Ask this question. If true, do this. Otherwise, skip past. So let's go and put some different numbers in there just to test that. So put 1 in there. Prints 1. Put 7 in there. Print 7. Change that to -3. Got -3. Change that to 99. And it prints nothing because it failed this, then it failed this, then it failed this. So logically, this is the way it works. But as I said a moment ago, it'd be much more common to write it like this. Oops. So do this, or do this, or do this in terms of ask the questions. All right? So let's look at the switch statement and see how that relates to this. So if I have an expression that can be reduced to a numerical value, or you could just put a number in here, I can use a switch statement and then jump to whatever numerical value this reduces to. So I have these case labels. These are keywords. And so this might be 3. So if the expression was 3, I jump to here and do this. And then unless there's break statements, we'll see examples of those in a moment. Unless there's break statements, this will continue to work its way down this list, including hitting the default. Now the default is there if it doesn't match any of the cases. So some things to consider: the labels need to be integers. So I can't say case cat or some other string. It needs to be like case 4 or -2 or 7.8, or technically you can have individual characters since they are numerical values. The default is optional. That's only there if it doesn't match any of the cases, but you don't have to have it. And then, as I said, once it finds a matching label, it just continues to work down unless it hits a break statement. So let's say we have this code right here. This says A is 3, B is 5. So 5 minus 3 is 2. So this will jump down to case 2, where it will say print countdown from 2. And then it just continues. It doesn't print case 1. That's just there to find out where to go to. But it would print countdown from 2, then countdown from 1, which is this output right here. So what if we want to do something like in my if statement and not continue on? Well, then I can include break statements. And not all these have to have it. It's just whether or not I want to break. So in this case, cost is 18. So I'm going to switch based upon the cost. It looks for a label that has 18 in it. Here it is, where it prints cost is 18. But then it hits the break statement, because these are really two different statements. I could have formatted it to say print cost is 18, semicolon, on the next line break, but I just chose to put it here. This break causes it to leave this block, so it never reaches case 75. Right? So this right here is closer to my if statement or if else structure. So why would I use the switch as opposed to what I had before? Let's go back and think about this example right here and see how I would use it or construct an if-else construct that does the same thing. And it will make more sense why a switch statement can make sense or be more useful. To make it similar to what we had, we'll say cost, we'll jump right to it. Cost is 3. And remember over here I said that if you get to 3, then you print countdown from 3, countdown from 2, countdown from 1. You'll do all 3 of these. So how are we going to match what I have over here? If that's equal to 5, then do something. And right now, the way I'm writing it, it doesn't actually match. Logically, it doesn't match. I'm typing less, so I'm just putting these numbers in here. So this says jump down to 3, which is slightly different. This is jump to 2, but I'm trying to make a point that this isn't correct. This right here does not match this yet. So notice it just did 3. What happened to everything else? Well, I only said print 3. I only get to 2 and 1 if you have those specific cases. So to match this logic, I need to actually do this. Let me, I'm going to put the semicolons on these lines. I mean the curly brackets. And really, I don't need this one. So now I got 3, 2, 1. Let's change it to 5. Five, 4, 3, 2, 1. So notice that when I use the switch statement, if I were to have b minus a be equal to 5, I would jump to this line, and because there's no breaks, then I just continue operating on these statements. And there's only 5 of them written here. But here, I had to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 statements to do what these 5 statements do. Because when cost is equal to 5, if I want to print these 5 lines, I need to explicitly say print these 5 lines. There's no way to say jump down into this section, then jump in this section, jump in this section, and so forth, like the switch does. So to do this, it's much easier to write the switch version than it is the if-else version. But I can always write an if-else version of what the switch does if I'm willing to put the effort into it. All right, so let's look at the conditional expression operator, which is sometimes known as the ternary operator because it consists of 3 parts. So the parentheses here are actually optional. I put them in here to make it more clear. If we look at operator precedence, you can see here's the ternary operator. So if I'm doing, say, addition or one of these other things, these have higher precedence, so these are close to the end. It's only when I put in an equal sign that I have something even lower. So what does this do? Well, this says it's going to ask the question, is W less than 14? If it is, if this evaluates to true, then X will be assigned a value of 10. If W is not less than 14, then Y is assigned a value of 19. That's the way this works. So if I wanted to do something like this right here, if W is greater than 14, give answer a value of 28. Otherwise, give answer value of 16. I could just write like this. Or likewise, what I could say is if W is less than 14, X equals 10, else Y equals 19. That's the the equivalent of this right here using if else. So once again, I can always replace this with an equivalent if else. It's just that there's certain situations in which this can be used where I would have to jump through a few more hoops to use an if else, because this can actually be part of a larger expression. I could not say answer equals if something else, something else. So this demonstrates once again what I said before. Here's an if else construct. Here's an equivalent ternary operator construct. So notice that the ternary operator is prints these statements right here. So this does this. But notice here that I've used the ternary operator as part of the printf statement. It would be illegal to say print x is %s, which is the format specifier for strings. That's what these are. It would be illegal to say x is %s, comma, if x less than 10, etc., etc. Now what I could do is say if x less than 10, print x is small, else print x is large. Similar to what I've done here. But there's times when maybe it just clicks in your brain to include this as part of some other expression. But there are people who think you should never use the ternary operator because I would argue it rarely makes things easier to read. All right? So those are the 3 types of conditional expressions that are available within C. So let's introduce some more logical operators. And I will actually do this in the next video because this video is getting a little long.